Hello, everyone. My name is Dr. Angelina Tsacheva, and today we will be talking about data and data analysis. So this lecture includes what data is, and especially relational data, which has attributes and objects. Then we will talk about the types of data that exist, the quality of the data, and then we will look at some initial data analysis techniques, such as similarity of objects in the data and the distance of the objects in the data. And we will discuss pre-processing of data, that is, preparing the data for analysis. So what is data? Give me just a second, because I'm trying to write something on the screen here. Okay, so what is data? So the relational data would look in a form of a table. That is, it has attributes that are the columns, or they are also called features or descriptions of the objects. So the attributes are on the columns, and they are description of the objects. The objects themselves are on the rows, so they are also called records. Or the rows. So these are the rows of the table. So as you can see here, the rows are numbered 1, 2, 3, 4, 5, 6, 7, 8. And then there are certain, and there comes the data. So what is inside of the table is the actual data, this right here. So there are some values for the attributes. So let's say the rows are customers, or these are people. And then on the columns, we have descriptions of those people. Let's say, what is their marital status? Are they single, married, or divorced? What is their income? And then did they receive a refund for their product that they purchased? So those are the descriptions of those customers. We call them objects because they could be customers, or they could be medical records. So this could be patients in a hospital, or this could be students in an educational data, or they don't need to be humans. These could be transactions in a transactional database, like when we go to a grocery store and we purchase a bunch of items, let's say bread, milk, fruits, then that goes recorded into the rows. So those could be transactions, they could be biological data such as human genes and genomes, or they could be climate data such as the temperatures, the rainfall, the sunny or rainy climate conditions. So that's why we call them objects, because they could be anything. In addition to human customers, patients, and students, they could be all anything. So we call them objects. So the attribute is a property or characteristic of the object. So for example, eye color, temperature, attributes are also variables or fields, and they are also called dimensions. And this is very important because when we start doing data analysis, we could visualize this data as a plot, let's say, in a coordinate system that has X and Y coordinates, and then the objects, according to their values, are plotted into that coordinate system. Then the attributes are used as the dimension. The first attribute is the X coordinate, the second attribute is the Y coordinate, the third attribute is the Z coordinate. So this means we will have a three-dimensional space. If there are three attributes, we have a three-dimensional space. If there are two attributes, we have two-dimensional space. If there are 43 attributes, we have 43-dimensional space. And this makes a difference because when we start doing data analysis, the number of attributes that we have makes a difference about the complexity, the time, speed of how fast our data processing will go. The more attributes we have, the slower or more complex it will be to run those algorithms. So we always want to be mindful about the number of what attributes or dimensions that we have. A collection of attributes describe the object. So the object is known as a record point, and it's point because like I said, we can map them into space. Either 2D space, 3D space, or more as needed. So that's why they're called points, because they are looking like a point in a coordinate system. They could be called cases, samples, or instances. So as a general term, we call them objects. So it's called the relational database, what you see here, because the objects could have relationships. So because of that, it's called relational database. That is, we can have more than one of those tables and link them together logically according to the relations between them. So let's say this is a table of customers. We can have another table of the products that they purchased, or what products do we offer, our inventory. And then we can link those together by the transaction ID. So TID is transaction ID. That is, the customer purchased certain products. So those would have a relationship. Those two tables would have a relationship between them. So this is also called a structured data because it has rows and columns and it's structured. Because we could have an unstructured data as well, which means it is not in a form of a table. Let's say the data on the web, the World Wide Web, all the web pages and links between them. They are not relational data. They are in a form of a graph, right? They have these web pages that look like circles and the links between them. This is an unstructured data, so we could still turn them into a table by extracting certain properties, like what's the name of the web page, what type of information does it contain, is it educational page, is it about food and cooking, is it about travel and entertainment, and then we can extract the data from those pages and put it in a form of a table if we would like to analyze it or give it some structure. But there are other forms of data in addition to tables. We will look at them in a little bit. Another thing to be noted here is the tables could have missing values. So the table could have a blank space in some of those fields here. And how do we handle that? We can either fill in the blanks, or we can ignore those records that have blanks when we start doing our analysis. So the attribute values, this is what I have enclosed in that rectangle here. This is the values of the data. So the attribute values is what's inside of the table. They could be numbers or symbols that are assigned to an attribute for a particular object. When we say symbols, this means that they can be text, such as strings. They can be numbers, negative, positive, floating point numbers, whole numbers, or they could be other things like images or sounds. This could be a musical database. So really, they can be anything. So we have to define the type of the data that we are putting into the table. Different attributes can be mapped to the same type of values. For example, attribute values for ID and age are integers, but properties of the values would be different. So what types they are? Like I said, we had to define the type in order to know what kind of data we contain in the table, and in order to create the table itself in a relational database management system, we need to specify the data type. And so these are the types that exist. The nominal would be ID numbers, eye color, or zip codes. For example, ordinal type of attributes are the ones that logically have an order. One is higher or lower or better than the other. So rate the taste of your potatoes, for example. Do you like these potatoes or not? On a scale from 1 to 10, how would you rate these potatoes? So this means that 1 is worse and 10 is best, and what's in the middle is middle ground, so they have an order. Same situation for grades, for example. A is a better grade than B is a better than C, right? So these would have an order. Interval. Certain data makes sense that it is given in a form of an interval. That's because, let's say, temperatures. When we are recording climate data or temperature data, we could have a really infinite number of values for the temperature. If a temperature changes from 61 degrees to 62 degrees, really, it has to go through all of the numbers in between. 61.1, 0.2, 0.3, 0.4. By the time it will turn to 62. We don't want to record all of that stuff because we don't have infinite amount of memory in the computer. So we need to create an interval. That is, we're only gonna record the temperature between 61 and 62. So we're gonna say the temperature was from 61 to 62. We don't care what happens in between those two numbers. We're gonna record an interval like this for the sake of saving space and having less number of values in our database. And then we have ratio. This kind of data makes sense if it is divided. And so we take it as a ratio, for example, length, time, or counts. So here are some properties of the attribute values. So the type of attribute depends on which of the following properties or operations it can perform. So distinctness, if we have, for example, a binary attribute, it's either 0 or 1, then we can tell 0 is different than 1. Or we have two zeros, 0 is the same as 0. So this is a distinctness property. Order, we said one is bigger or smaller than the other, such as the grades A, B, C, D. Some of them might make a difference if we subtract them and divide and add them and subtract them, and others make have a meaning if we multiply them or divide them. So here is a table of the properties, for example. The nominal would have distinctness. The ordinal will have this bigger and smaller property. The interval will have subtraction and addition property, and the ratio will have multiplication and division property. So like we said, example nominal attribute is zip code, employee ID, male or female. Ordinal would be grades or good, better, best. Interval will be temperatures, and a ratio, age, mass, length, and so on. We also have to note that we can have numbers or numeric attributes, which are also called quantitative, or categorical attributes, which are called qualitative. So if they are numeric, if they are numbers, they will be called quantitative. And then if they are categorical, that is, they are text, then they will be called qualitative. Another important thing to note here is what I said earlier about the temperatures. So in the real world, temperature would change from 61 to 62 degrees. By the time it does that, it has to go through all numbers in between, 61.2, 0.3, 0.4, 0.5, 6, by the time it gets to 62, right? This is called a continuous attribute. That is, in real life, it has an infinite number of values. And we want to, in order to record this in a computer, we want to make this attribute discrete. That is, we're going to record an interval from 61 to 62. Because we need to be able to save this in the computer, right? We don't have infinite amount of memory. So we have to discretize the attributes. So to make it discrete, it means that it has finite number of values, exactly the ones that we choose. That is, we are sampling this attribute. We're taking samples. We're only going to measure 61, 62, 63, the whole numbers. We don't care about those 0.1, 2, 3, 4, 5. So we're going to make the values finite by taking specific values only that we care about. There are some attributes that already are discrete, such as zip codes or counts or set of words in a collection, so there's no need for us to discretize them. But really, in the real world, the natural things that we measure, most of them are continuous or infinite. So if we are to take a picture with one of those old cameras that will put the picture on a film and print it out on a paper, it would be a continuous picture. That is, it has an infinite number of colors and pixels. If we want to save this picture in a computer, we have to discretize the picture or give it some pixels, 512 by 512, in order to save it like this. So this is to make the picture digital or discrete. We're gonna take samples. We're only gonna record 512 points, and that's it. The rest of the information is really lost because it has infinite number of pixels. So attributes could be symmetric or asymmetric. Here's some related literature on the description of attributes in the data. So, like I said earlier, for pre-processing of the data, that is preparing the data for data analysis, we need to take into consideration certain factors. One of them was that the data could have missing values. If it has missing values, we need to determine what they are either, or just skip those objects from the analysis. Another thing we have to consider, the data could have incorrect values. That's called noise. So data could be noisy, that it could be dirty, that is, it has incorrect information recorded in the data. Let's say an age of a person is between, if our customers is between 25 to 80 years old, and all of a sudden there comes some customer that's 315 years old. Is this possible? Most likely is a mistake. That's called noise. Nobody's 315 years old, I mean, that is living. So this is called noise. So the data could be having incorrect information in addition to having missing information. So we would need to clean that up before we start the analysis. So this can complicate recognition of the proper attribute type. And it could be correct or approximately correct. We could perform certain transformations on the data, such as putting it into intervals or mapping numbers. Let's say we don't want to have numbers in thousands or millions, but if they're that big, we're going to map them to smaller numbers from 1 to 10, for example, for our analysis. So that would be a transformation of the data values. So like I said earlier, the relational data comes in a form of a table, but we could have other structures of the data, or we could have unstructured data altogether. So if we have a record data, it looks like a matrix or a table. And that's what we would be using for our relational databases. But the data could exist in other structures, such as a graph. Like I said, like we mentioned earlier, the World Wide Web would be all the pages and links between them. So that kind of looks like a graph if we are to visualize this data. So let's see how they look like. Some characteristics, dimensionality, like we said, is the number of attributes and or dimensions. It makes a difference how many we have because that could complicate the analysis of the data. So record data is when we have a table format or relational data. We could have a data matrix so that some information was extracted from those tables. And we created a document that contains the information. So that's called a data matrix. Document data, document 1, 2, 3. And let's say, does this document contain the word team? Play, bell, score. This document contains the word team 3 times, contains play 5 times and score 2 times. So we're to count the number of times this word occurred into the document, we could create a data matrix like this. So we have document 1, 2, 3, 4. So this could be used for analysis of websites, for example. Does the website contain specific keyword? Well, you would think this is important because search engines really need this, right? They need to know if the website contains specific word. So they're going to create huge tables like this for all the web pages on the web. That's why Google has those Google Pregel APIs for large graph analysis, so that it needs to know the keywords for all the web pages in the web, in the internet. So this is important. We could turn the unstructured data of the web into a structured form like this and put it in a table for analysis. Transactional data is a special type of record data. That is, it does not contain objects like humans, customers, patients, or students, but it contains transactions. So what are specific items that a person purchased when they went to the grocery store? So this person purchased bread, Coke, and milk. That's a transaction. That is a set of items that was purchased. Item A, B, and C. And this is what we will record into the table. So it involves a set of items. Set of products purchased by a customer during one shopping trip is called a transaction. Now, what about the other ones? Like we said, the World Wide Web does not look like a table. It looks like a graph. So let's say each web page is one of those red circles here, and the arrows between are the links. The first page has a link to the second page, so then an arrow is placed. If both of them have a link to each other, then this double arrow is placed here. And the one picture on the bottom, again, doesn't look like a table. This is a chemical data. This is a molecular structure of the benzene. This is the gas that we put in our cars to run our cars. This is how it looks like. That's its chemical structure or molecule. So we could have biological data, graph data that is it has it doesn't look like a table. It has a different structure. So sequences of transactions. It is important that in the order in which those happened. Another important order could be if we have biological data of the human genome, it kind of looks like this. So these are proteins, and the order that they come in makes a difference. This is how our DNA looks like. So the order here makes a difference. But it doesn't look like a table, right? So I'm just trying to show that there are data that are structured, that have their own structure different than a table. Here's the spatial data, spatial temporal data. This is more of a visualization of the temperatures, the monthly temperatures of the land and the ocean. So you can see here the blue ones is where it's very cold. It's way below freezing. Now up here we have the North Pole, those dark blue areas. The green and the yellow are temperatures like what we have in California, about 10-15 degrees Celsius. And then the red ones are really hot, like what you would have in India, for example, 20 to 30 to 35 degrees. And here Australia is really bad. It's almost like 45 to 50 degrees here. So this is just gonna use the color to show the temperature in particular areas on the planet. So quality of the data. Like we said, the data could contain missing values or noisy or incorrect values. So if that's the case, we need to clean up the data before we start making any analysis on the data. This is very important because data quality would cost a company 10% of their revenue. So the data need to be cleaned up. So if we are, let's say, to detect people who are at risk for repaying back their loan, let's say we want to evaluate a person based on their credit report, if we should give a loan to that person or not. Then obviously data needs to be correct about the person, or else you could be making a false positive or a false negative decision. So the data quality is important. What are the quality problems? Like we already mentioned, there could be noise, there could be missing values. There could be duplicate values, or plain the data can be incorrect. So what is noise? Like we said, noise is data that is contaminating the original data. We could think of it as sound that helps to give a real world analogy of the noise. Let's say somebody pressed the piano key. The piano key is the green line here. It looks like a sine wave, and it just goes like this through the electromagnetic spectrum. You press a piano key and it goes like this. That's one wave right here. Then a person pressed another piano key, maybe a lower one. Then you have the blue line here. There are exactly two sine waves for the two piano keys. That's called a pure tone. Now, if somebody came up, there's an airplane passing by, or a big truck on the road, or somebody's cutting the grass, there's a lawnmower making a lot of noise. And if we're recording this piano keys, we're going to record the noise as well. And this is what it looks like. So this is visualization of a sound wave here to show the mixed in noise into the pure piano key tones. And then we have those outliers. This is the guy that I said that he was 315 years old. So most of the people in the data are between the age of 20 and 80. And this is where here are the 20 years old, here are the 80 years old. Years old. Cluster 1. And then here are the 80 years old. And there are some other ones in between that are 30, 40, 50, 60. But this guy right here, he's only one single person in the entire database has this age, which is outside of all the other ages on the plot. So this guy is really not related to any of the other data. it's called an outlier. If the guy is 315 years old, that's an outlier. So these are objects with characteristics that are considerably different than most of the other data objects in the set. Okay, like we said about the missing values, they can be handled by eliminating this kind of objects altogether. That is, we will not consider them at all, or we could try to estimate or fill in those missing values, and there are different algorithms that can do this. So those are algorithms that would be imputing the missing values. They are going to determine what the values are and fill them in. And then how do we handle the duplicates? So we need to detect the duplicates and eliminate them. So data cleaning is a process that deals with all of the things that we just seen. That is missing values, outliers, duplicates, and all of those is really handled by data cleaning techniques. Okay, so we will continue next time about the similarity and dissimilarity between the objects in the data.